Hello, everybody. Welcome to the 6th bootcamp session. Hope you all are having a good Monday so far. Any questions about any of the, I guess, the last project milestone or anything about React before we get started with today? Sweet. So we'll go over today's agenda. It's going to be going over HTTP and then what are APIs and then using fetch. And then we're actually going to have a demo, which is connecting with your own server. Just a reminder of where we are. Today we're on the 6th one. We're nearing the end, so good stuff for getting it this far. A note is there's not going to be there's no boot camp next Thursday. There's the general meeting, and that's going to be held this Thursday. Sorry, that's this Thursday. And that's going to be held in room 14249, same one as the first general meeting, and we're going to be meeting the nonprofits. So hopefully you all can be able to get out to that meeting. If not, it will be recorded, but it would be super good for all of you to go and meet some of the people who are going to be working with this year. And we have, as always, our review Kahoot. This one's going to be on React. Oh, oops. Oh, I hate every time I press escape, the meeting controls just have to come up. Just have to. Hide it. And it's always hard to like find where that is. There's guest. There's guest. Classic. Full volume. Maybe we have to hit the laptop button or auxiliary. I don't want to risk it right now, but maybe aux. That's how it works with my old-fashioned TV.
I mean, it's HDMI. Scary. Whoa.
That's cheating. Only 2 per team.
No, don't do it.
Are the game it's always 7 letters? I thought there were 6.
What?
Have they always been 7 letters? Or characters? Yeah.
Yeah, that's a good question. I think it's been 7. I thought it was always 6.
Maybe they ran out.
Yeah, just too many games.
Is everybody in, or looks like we're still waiting on a few more? There. I think, is anybody else? Sweet. Should be good to go ahead and get started then. Oh, maybe this. No. Oh, I should full screen.
Yeah.
I mean, I guess if you said red, you technically wouldn't be wrong.
Well, no. Well, that's but it allows us because we could already do that before if we had React.
That's true. Good stuff on the first one. Again, good stuff, good stuff. Freaking Ryans are always at the top.
Yeah.
Ooh.
Yeah, so when you start a new React project, the home page, which is similar to like the index.html when we were using plain HTML, it's always going to be called app.js, and that's going to be the component that gets like always rendered on your page.
Ooh.
Yeah, that's it.
Yeah.
They're sneaky. So yeah, Yarn is another package manager like NPM. But I think by default it's preferred in React, but you can use either one, whatever works best for you. I think React will tell you to use Yarn to start though in this documentation. What if you style components?
Well, styles is-
Good stuff.
Nice.
Okay. Sweet types.
Yeah, you can select multiple for this one.
Oh, that's weird how it gives you the answers, but
Yeah. So functional components are going to be the ones we use most often. The class you'll also probably see a lot when you're looking at like Stack Overflow or the React docs. They're both good, but we tend to use functional more here.
I wish there was the music. Kahoot music is so good.
Okay,
Ooh.
yeah, this one was okay. So when we're using HTML, you use the script tag to kind of connect that CSS to the HTML. But when we use React, React is quirky. So we use the import statement in JavaScript. So similar to how you can import a JavaScript file into like another JavaScript file, you can import a CSS file into a JavaScript file, and then it kind of connects the two. Does that make sense? Cool.
This one's pretty tricky. Sneaky.
Yeah.
And the first one is the name is a bar. Is that like a comment type
That's a
of thing?
comment. Yeah. I probably should have double slapped. Yeah.
Ooh.
Okay, so for the red, if name is a variable, the name would be a JavaScript variable, and you can just put it directly inside of the curly braces. Everyone got the blue one right. That $ would actually be rendered, unlike in a template literal, which is like the back quote ones. The yellow one, that's the tricky one. React is actually smart enough to take a list of HTML elements and then just render them back to back to back. So yeah, I could see why that one could be tricky. And then the green one, that's the one that's wrong. You can't just put the word return because then like JavaScript doesn't know how to like handle that.
And so that one will always throw
Yeah.
an error.
So also one more thing to note, that's why we can use like the map function or like the filter function directly in the curly braces, because those return an array, and the React will take that array and render the proper HTML from that.
Ooh. Final question.
Nice. Yeah, so that blue one is just a variable. The red is just another way of writing functions in JavaScript. We have arrow function syntax and then kind of the regular function. And then not listed here are the class components.
Sweet. So let's see the podium. I built. Ryan, do you still have your prize? Oh. 9 out of 10. Good stuff.
Ooh,
And then in first we have Ryan.
right?
Guess he keeps his candy. Good stuff, Ryan.
Honestly, I'm giving it away.
I see. I see. Sweet. So hopefully you guys enjoyed that Kahoot. Yeah, no stress if you got some wrong, but it should like give you a reminder as to what we learned last week. And hopefully you start to like see some of the syntax and it starts to look a little bit more familiar. But moving back to the presentation, we'll start to get into today's content. And
All right, so first thing we're going to be going over today is HTTP, and this is going to kind of like, as it says, make your computer websites more extroverted, I guess, and allow us to talk with other things on the internet. So just kind of a brief overview of kind of what we've done so far, what's coming up. So the things that we've done so far, we can create kind of more complex websites with React. We can get user input, respond to and interact with users with JavaScript stuff that we've learned. And then we have a lot of those development tools that we've gone over with GitHub, Node Package Manager, Git, and other things like that. So a lot of the stuff we've kind of taught you all so far, these are most of our front end tools. So this is stuff that when you're coding with it and developing this kind of stuff, it's going to interact with the users. And now is kind of the stage where we're moving more towards the back end and doing some different types of tasks and doing new things with our JavaScript. So things we're going to talk about today is we're going to make kind of like changes that users make on our website, kind of saved in a database. And then we're going to communicate between our front end that we've put together with our website so far and those databases. And kind of moving forward, we're going to be talking about middleware and backend. So the backend is going to be, again, that database where we're storing data that users input. And then middleware is kind of the code that we're writing that connects that front end stuff with that database, stuff that the user's not really going to see, but it's also not like living in another server or on the cloud. So first, let's talk about what HTTP is. So it stands for Hypertext Transfer Protocol. Not really an acronym you need to know, just kind of interesting to think about. And then basically HTTP is the standard for communicating information across the internet. So essentially it's a format of transferring data between computers and other servers. And again, like I stated earlier, it just kind of allows our websites to talk with the internet and other places that we may need to. So a little bit of important vocabulary when we're talking about HTTP. So the first thing we want to go over is what the client is. So this is the program that kind of acts on the behalf of the user or whoever's on the website. And typically this is going to be our browser, right? So if you're interacting with code on the browser, that's going to be the client side of the HTTP interaction. Next, we have the server, which kind of hence the name, it serves the information that the client's asking for. So you can think of it kind of like a relationship at a restaurant. You'll have someone sitting at a table asking for food. That would be like the client, and the server is going to be who's going to bring the food back to the table. So, and then the main two important parts of HTTP are the HTTP request, which is kind of the information that the client sends to the server, telling them what they want. And then we have the HTTP response, which, hence the name, is the response from that server telling the client, what information they needed or the status of that request. And the way HTTP interactions work is they happen in kind of this step-by-step request and response order. So there's not going to be a ton of information flying back and forth at the same time. The client has to make a request to get information, and then the server is going to always give it a response, whether it's a good response or a bad response. So anytime you're going to need data from a server, you have to send a request, and it will always give you the response that you need. Okay, so first we'll talk a little bit about the structure of an HTTP request. So there's 4 main components of an HTTP request that are just important to kind of understand. So first we have the method of our request, and this is probably the most important part because it kind of summarizes what the request is going to be doing. So there's a couple different options. Some of the examples I have listed up there are get, post, and delete. So if you send a get type request, what that's going to be doing is asking the server to get you information. So it's pretty self-explanatory in the name. A post type request is going to post data that you're sending to the server into that server's database. And then a delete request will tell the server what to delete inside of its database. For right now, when we're learning this initially, we're only going to be using get requests. So we're just going to be asking for things and then getting returns from the server. We'll learn more about some other options later, but get's the main important one you need right now. So next we have the path of our HTTP request. Essentially, what this path is if you just need information from like a specific area. So we have examples like recipes or ingredients. So if you're trying to get information about a specific recipe, you'd maybe put a recipe path. If you need, maybe images from a general image folder, you could put images as your path. There's a lot of different options there, and there will be resources on the Notion talking more about paths and how to use them. But that's really all you need to know about them for now. We have the version protocol, which is the other thing on that image there, and that's going to be pretty constant for most things. That just kind of tells the server what version of a request you're using, so it knows what format the data is. And then the headers, it's going to have other information that the server needs to fulfill the request. So we can see in the green box on the bottom, the main component of any header is going to be the host. So in this example, it's developer.mozilla.org. And that's just basically the server that you're requesting to. And then the last thing is the body. Not every HTTP request is going to have a body. But for example, if you were making a post data request, you may include some data inside that post request that is the literal data that you want to post to the server. So it's not in every request, but something that you will see sometimes. And then we have our return from the server, and this is going to be our HTTP response. It looks pretty similar, so a lot of the same components. So the version protocol, again, it's going to be the same, telling the client side what format the data is, so it knows how to interpret it. So the main difference we have is the status code or status message that you can see are those 3 numbers in the middle of that top line there. And there are tons and tons of different status codes that mean different things. You definitely don't have to memorize all of them. This is something that you just look up anytime you saw a status code, but the most common ones are 200, which means everything is good. It did what you wanted it to. And then 404, which just means it has no idea what you're asking for. And that's going to be your typical error when you see that. And then you can see there's a lot more header information in a response, but this is not stuff you typically have to like parse through yourself. This is just stuff that the client's going to be using to decipher that data.
Sweet. Any questions on HTTP so far? So now we're going to be, now that we kind of know what an HTTP request looks like, now we're going to talk about how they're useful. And one way that's really useful is when they're used or paired with APIs. And here's a quote. So APIs are programming features for manipulating different aspects of the browser and operating system this site is running on, or manipulating data from the other websites or services. So moving on to what an API is, API stands for an application programming interface. And APIs, what they do is they allow us to use data from other websites and databases. So a lot of companies like Spotify, Twitter, Instagram, they'll have APIs where you can actually like do stuff and kind of interact with them. You'll send some HTTP requests from them and they'll give you a response. And we'll kind of have it, not a demo, but we'll have an example of the Twitter API in a bit. And then, so yeah, as mentioned, most APIs will use HTTP communicate information. I don't know what the other options are, but HTTP is very common, so I'm sure you'll use a lot of those. And yeah, so an API is kind of what you're using, and an HTTP is how you use it. And then yeah, a lot of companies will have their own APIs, and there are also open source APIs and unowned APIs. And sometimes you'll need like credentials to access them. So if you're going to access the Spotify API, you'll probably need to either get an account and create it because they don't want you spamming their API because that's going to cost servers. So some companies will have protected APIs and others will just be open and you can access anytime, anywhere. So interacting with APIs, here you have the computer, which is you, and you're going to send an HTTP request over to an API. In this example, it's going to be the Twitter API, and they'll send you a JSON response back. So kind of comparing what this might look like and visualizing it. Using the Twitter API, you can use a HTTP request and you can use GET, and then with that path, you can do a user, and that :ID thing you're seeing is actually going to be unique. That'll be kind of the Zimbo boys, and in this case, that's actually Ethan's Twitter if you want to follow him. So if you did send that HTTP request to the Twitter API, you'd get returned that object below, and that's going to be a JSON object, and it's going to contain some information about the user Zimbo boys in this case. So it'll contain things like his ID, his name, his bio, his list of followers, and there can really be a lot more. If you look up the Twitter API, you can see there'll probably be hundreds of different requests you can run, and each one will return you with different information, but kind of seeing it in action. Again, you're going to send that GET, and then you're going to send the path. That's not a full HTTP request, but that is an idea of what it might look like. So you'll send that, the path, and then the ID, the Zimba boys at the end, then it'll go with the Twitter API, and that'll like route it, and it'll return to you that information. And that's kind of a very quick overview of what APIs are. A lot of you have probably accessed them in projects before or might be familiar with them. Hopefully that wasn't too quick though. Are there any questions about what an API is at this moment? Sweet.
Okay, so now we're going to go over fetch, which is the function that's built into JavaScript that allows us to make HTTP requests. So as I just said, a fetch request is one of the most common ways to send or receive data from an API. And it's a function that accepts two parameters. The first is a URL. So that was like that path that Ben was talking about that had like a string. And then there's the second optional parameter, which is where everything else goes. So that's where you can put your headers. That's where you can put your body. But the most simple like HTTP requests, you won't even need to include that second parameter. And then fetch is an asynchronous function, which we're going to delve into a lot today, which makes it a bit wonky in how we deal with calling that function. Okay, so the fetch syntax, first input is a string, which is the URL. Second is the options. A URL is pretty straightforward. That's just telling you like what the name of the API is you want to call, or whatever like HTTP request you're sending. And then one thing to note is that you may also have this thing called a query param, which is like, it's another way to pass data through an HTTP call directly through that URL string. So if you look at the bottom example, it says await fetch, and then there's a string, and then there's like a question mark name equals Vance. That question mark name equals Vance, that's called a query param. And that kind of allows you to pass a variable straight to that API without having to pass in like an extra header or body or anything like that. And then options, that's where you specify everything else. So if you're not making a GET request, you need to specify that your method is a post or delete. So if you look at that top example, the string at the top, that's the URL you're sending the request to, and the method is post. And then you can send in headers. The most common header you're going to send in is a content type, which specifies what the like data structure of your body is. So most of the time it's going to be JSON, but you may also see like form data occasionally. And then finally the body. And most of the time that's just going to be straight JSON. And you can call this method called JSON.stringify, which takes an object and packages it into a nice JSON piece of data that you can send. Okay, so that's kind of the general syntax. And now we're going to go a bit into what that await keyword means. So before we talk about asynchronous programming, we just have to explain what synchronous programming is first. So up until now, all the JavaScript we've been coding in has been synchronous. So each line does not execute until the previous line. So if I say x equals 5 and then I console.log x, like we always know that x is going to be 5. That's just the flow of code. However, synchronous code can experience blocking, which occurs when an expensive operation, and when I say expensive, it just means like time consuming. When an expensive operation prevents the code after it from being run. So if I say x equals 5, and then I have an infinite loop, and then I console.log x, like you're not going to get much from that function because it's just going to get stuck in the infinite loop. So you're never going to hit that console.log. So that isn't great for websites, because if you had like a while loop that just counted up to like 1 trillion and then console.log x, you're going to have this like weird loading buffer where the user can't interact with the website that you want to avoid. So that's kind of where asynchronous programming comes in, is it allows the computer to recognize, hey, this part of the code might take a while. I'm going to like set this aside, and then I'll come back once this part of the code is done, and then I'll keep running the rest. So a fetch request might take a second or two. So JavaScript might return and like do some other stuff in the meantime. So that way users can keep interacting with your website while that fetch request is going through. Okay, so this is like a simplified version of what asynchronous code is. It allows JS to go to other code that normally would have been blocked on. So if you look at the top layer, it's synchronous, so it goes products, then customers, then orders. But if there's a fetch request in your products that's just kind of hogging up all this time, you can make the fetch request in products, and then during that time, you can kind of address whatever's happening in that customer's line of code. And then once that fetch request is over, you go back to products, and then it will finish with orders. So what you really need to get out of this is that whenever you're making this asynchronous call, you want to kind of free up time for JavaScript to do other stuff. And luckily, JavaScript has a pretty clean syntax that allows you to do that. So whenever we make an asynchronous function call, JavaScript will return a promise. So there are certain functions in JavaScript that are just denoted as asynchronous. Like you're given a fetch request, you're given the fetch function, it is always going to be asynchronous. And before this promise is resolved, it's going to return just an eventual completion or failure of asynchronous operations. And when we get a promise, we want to handle it, which means kind of wait for the promise to actually come to fruition and give us some form of useful data. So that's where the two kind of ways we handle come in. So we either use async and await or .then. So as I was saying, an unhandled promise is not going to be very useful. So if you look here, I have 2 lines of code. The first one makes a fetch request to this API called ageify. It's a really dumb API that guesses your age based off your name. And then the second line just tries to console.log age. And then below that, you'd look at the response. that would happen if you just ran these 2 lines of code. JavaScript would just say promise pending. Because what happens is you run fetch and then the promise isn't resolved. The JavaScript just doesn't know what to do. So it keeps going to the next line. So it gets the age and like age still doesn't have a value associated with it because the fetch request actually hasn't been fulfilled yet. So you kind of initiated the fetch request, but you don't actually know if it's done yet. So the way we handle that most often is with these keywords called async and await. And these first bullet points will make a lot more sense once we get to the code example. But await goes immediately before the asynchronous function call, and async goes into kind of the function that contains the asynchronous function call. So just hold off on questions for that. It'll make more sense when we get to the demo, to the code example. But what this allows us to do is kind of prevent this blocking that I was talking about earlier. So when JavaScript sees the keyword await, it's like, oh, this is going to be an asynchronous call that might take a while. So it goes, does other stuff, and then comes back once it knows that that fetch request is done. One more thing to note is you can't use the await keyword without using async. You have to use them together or else JavaScript doesn't really know what to do. And another thing that's nice about async await is that if you do get like a bad response from your fetch request, you can just handle that with the normal try catch syntax if you've ever used that before. So it's similar to just catching any exception in another language. Okay, so here's the code example. So on the left here is kind of like an example of what you shouldn't do. So I just have this variable called Vance, that's my name. And I make this API call. And notice for this API call, we only use the first parameter. We don't deal with options because this is a GET request. There's no additional data needed. And then we console.log a.json. JSON just kind of takes away all the unnecessary part of an HTTP response and gives you the actual useful data that you need. So whenever you're making a fetch request, you're usually going to need to follow it up with .json. So if you store the fetch request in H, then it's going to be h.json is going to be where your useful data is. So in order to make this async await, the first thing we're going to want to do is wrap this in a function. So I wrap this in a function called getAge. And then if you look at the bottom of this function after like the closing curly brace, we call getAge. So we're running that function now. And in order to make this an async await function, the first thing we do is we put the async keyword directly next to the start of the function, which in this case is those 2 little opening close parentheses. So it always goes right before your input. And then whenever we encounter an asynchronous function call within this asynchronous function, we use the await keyword. So fetch is asynchronous, so we put await before it. And then another thing that's kind of confusing, .json is also an asynchronous function. So you have to put await in front of that as well. So we have 2 asynchronous function calls. There's fetch and JSON. Yeah, so that's the general syntax behind it is whenever you see an asynchronous function call, you put await. And technically this also makes getAge an asynchronous function call, but since there's no code after it, it's fine to not put the await keyword because we're not like expecting any data to come from that. And then one last note is if you're using like a non-arrow function, async goes right before the keyword function. So you can use it with arrow functions or non-arrow functions. And then .then, this is like an older way to use it. It's kind of ugly, but you'll probably see it if you go on Stack Overflow and stuff, so it's good to know. So the syntax for this is immediately after your fetch request, you chain it with .then. So you'd have fetch and then whatever you're fetching, and then you're calling immediately after that. Then it'll again make more sense once you look at the code example. Then we'll take a function as its input in parentheses. So then is a function call, and in that function, you pass in a function. It's kind of weird. It'll again, make more sense when we demo it. But that kind of allows them to run the code in your function once you pass it. You can chain multiple things together if you have multiple asynchronous function calls. So we normally have fetch and then .json. So you'll have one .then immediately after the fetch, and then another .then for the .json. The way you handle errors is a bit different for then. You use a .catch at like the very end of your .then chain. And then one last thing to note, async await and .then are like completely separate things. So you don't really want to intermingle them. So if you're using .then, you don't have to worry about the async await keywords. If you're using async await, you don't have to worry about .then. They're two separate solutions to the same problem. Okay, so code example. On the left, we have the exact same example of an unhandled promise on the right, or on the left, that's bad code. And then on the right, we're handling this fetch request. So we make the fetch request, and then after that, we have .then data, and then we call data.json. And then since that isn't asynchronous function call, we're going to have another .then after that .json call, and that will resolve the JSON asynchronous function. And then we can finally print it. So as you can see, async await, like at least in my opinion, is a lot cleaner and easier to read, but .then is a good syntax to know. And then one thing to note about this example that can make .then kind of hard to read is that we're using implicit returns. So if you remember way back when we were covering JavaScript, when you have an arrow function and it's just like a single expression, you don't need to use the return keyword and it will like automatically return. So in this example, data.json is being returned. So if I added like a return keyword before, it would mean the exact same thing. But just one thing to note for how the data is kind of flowing. Yeah, and then one then function per async await, or one .then per asynchronous function.
Are there any questions about any of that so far? Sweet. So now we're going to be talking about connecting with your own server, and we're going to be doing that using Express. It's also called express.js, and that's actually the E in the MERN stack. So Mongo, Express, React, and Node. At this point, we've seen Express, or we will see Express now, and then we've seen we're going to see Mongo in the next bootcamp session, and we should have already seen Node and React. So we should have some familiarity with what that means by now. And then moving on, what is a server? So as our definition was earlier, a server is a machine that serves information requested by the client. After a server receives an HTTP request, it will send an HTTP response back to the client. And then what is Express? So Express is that middleware that Ben was talking about at the beginning. It's what we use to communicate the front end and the back end. It's code we'll write that the user isn't going to see on the screen, but it's important to have it there as an will be used to kind of get information that might be ended up being displayed to the user. And Express is a node package, just like React. And what it does is it allows us to host a server on our computer and actually handle HTTP requests. And we'll get into a demo here shortly on it. And eventually in the project, we're going to be using Express to build an API that connects our front end with our back end. And setting up Express, there's going to be some boilerplate. You're going to, inside of a file that's probably located in the backend folder somewhere, you can have that boilerplate code. Const express require express, that kind of says we're going to use express in this file. Const app equals express. That's actually initializing express. And then we're going to use like app a bunch kind of as like a precursor to a lot of things we can do. So we'll see like app.listen 3000. And what that's going to do is that's going to be the port on which our code will be, or our server will be running. And then moving on to some route syntax, again, using that app, we can do app.get, and then our path, request and response. That's what REQ and RES stand for. And then you can actually do something like result.send hello world. And what that's going to do is it's going to kind of display content onto your server. So we'll actually go through this example and we'll see hello world on our server port 3000. So some, general syntax is the method that's going to be get, but if you're using a post request, a put request, or a delete request, or any others, you'll put that there. You'll still include the path name. Request and response are variables that you might not use, but you can go ahead and put them in every one. And then if you're going to use any other variables as well, or functions, you can go ahead and put them in that function call. And then we're actually going to go straight into the demo. Express is best learned through example. And while we're setting up the demo, we can actually go and like do that ageify thing Vance was talking about. I don't know if I don't remember exactly the route, so I'll go find it. But I think everybody should just do this on their own screen, and we'll see who has the youngest name and the oldest name. It might be kind of fun. So it's HTTPS dot this. I'll copy it and then I'll ageify or API slash ageify name is equal to Colt. So it'll return some JSON. Oops, I left a thing at the end there. So I guess the average person named Cole is age 34. That's interesting. If you guys try it, we'll kind of see who has the youngest name and who has the oldest name. And if you can't read that, it's just going to be api.agify.io, and it's going to be slash. That's a backslash, I think, then question mark, then name equals whatever your name is. Does anybody have like a super old or young name? I'll be curious. Let's see what Ben and Vance are in the meantime. Ben is 49. I feel like Vance is either going to be a super young or super old. Oh, never mind. Does anybody beat 49 for Ben for older? Oh, nice. Let's go, James. What about the youngest name? Anybody have like a, what is a young name? Okay, sorry. I'll go back to the demo now, but that was just kind of like a fun little thing that we could have tried. And so, yeah, so we're gonna create a new demo. We'll create a new folder and we'll put our Express inside of it. So we can create a new folder. I'll call it Express demo. And then we actually need to navigate into that when we do run our server eventually. So, oops. Oh, oops. And then we're gonna install Node here or initialize Node here because we're gonna use some npm packages. We can just kind of run through this really quickly. It's gonna ask a lot of things. Yes, that's fine.
Just press the enter button to like skip to the next step.
So the first thing we're going to do is we're going to install Express, and we can do that with npm I express. Let me zoom in a little bit so it's easier to see. That's too much maybe, but we'll roll with it for now. Might take a little bit. Sweet. And then we're actually going to install a package called nodemon. We haven't touched on it earlier, but what it's going to do is it's going to refresh your server every time you save. And that's just going to be helpful for us because that way we won't have to kind of restart, close our server, and then open it again every time you make a change. So we'll install nodemon, and while that's getting started, we can actually create our new folder, or our file, and we'll put Express in that. So we can create a new folder, index.js. We can see that was created here. It's empty for now, and we'll actually add that boilerplate that is needed. So const express equals require express. Then the const app is equal to express. And then we can actually do app.get and then that path. So here, and then request result, and then our arrow function here. And then we can actually do something like res.send anything we want. We'll say hello world for now, if I could type it. And then one final thing we're going to need to do is app.listen on the port we want. I prefer using port 3001 for the backend and 3000 for the front end. Sometimes you'll need to have them both. So I'll just call it app.listen3001. Now we can actually run our server. We can do that using nodemon, the package we just installed, and then index.js to run it on this file. And it says, okay, a server was started. And if we actually go to our localhost, so https://localhost 3000, and then just slash. Oh wait, that's awkward. tp://localhost 3001. I call it 3001. Then we can see that hello world is there. One other thing that I'm gonna go over, and it's gonna be nice, is we can actually create a variable called port. We're gonna set that equal to 3001. And we're gonna put this here as well. And well, that's just gonna make things easier for us. That way, if you have multiple times where you use your port, which is going to be common in some Express files, you'll only have to change it once. That's just a quality of life thing. So we can start kind of going from here. We could change it again some more. Hello world, my name is Cole. And apparently Ageify thinks I'm 33. But we can go ahead, refresh it, and we'll see those changes there. This isn't that a pretty like simple example. So we'll add another route. So we can add one maybe like that might be useful in our project. So we can add something like recipe. Again, I might just copy some of this syntax here. So we have our request and our result. And then we can do something like res. I don't know, we can do something like console.log hi, and then we'll also do something like res.send this is my recipes. So now if we navigate back over to the recipe route, so in our thing we can add /recipe. We'll see we're on a new page and it says this is my recipe as it should. We should have also seen hi in the console. That's just kind of one more thing you can do. This time, since it's gonna express the console.log is not gonna go to the, actually I don't know if it goes into this console as well. It doesn't, it looks like it's just gonna exist in your terminal console. And then this is kind of where we can start to do interesting things. So we can actually, in the like Ageify example, we can add something like the question mark and then a variable. And these are going to be those query params Vance was talking about earlier, where you can do that. And that's not interesting right now. But if we go back in here, we can actually access these query parameters, which is actually pretty interesting. So we could do something like const recipe name is equal to our query request. And then we can do query.name. And we're not doing anything with that variable yet. But now if we wanted to like log our information, we should see whatever we saw up here. So pasta. And we'll see that once we refresh. And that's kind of cool. One more thing we can do is something like using that string syntax use variables. We can put that inside of our syn. So this is my something page. And we'll just see that if we refresh, this is my pasta page. And we just were able to do that by adding that query parameter into our server.
It's not fair what you call the query. Like in the browser, you call it like anything equals pasta.
I believe so. Let's try that. Anything equals pasta. So this one probably won't work because in our thing, it refresh it to name, but this is my anything equals pasta. Enter. It's going to say undefined. But if we go back in here, we can access that with request.query.anything. That should fix it, and it'll be pasta. Any questions, other questions about Express? Yeah, right.
When I join supply with a query, it just says it's undefined. Like, how do you handle if like nothing comes in? No query.
Ooh, like without this?
Yeah, without that, it just says it's like undefined.
I guess that's probably a good example of you shouldn't be using variables to do anything when you're not, when you may or may not have a variable. I guess in this case, we probably have to handle that with like if recipe name is not, wait. I should know how to make it not null. Is false, yeah. Oh. Then we could oh god, not equal false. This doesn't look good for me. If recipe name is not equal false, then we can run that. And that's kind of just a way to prevent that from happening. Now nothing should happen. And then does that make sense? You just that's not a good practice to do it like that. You'd have to handle that
It's
if
the
you
job of the middleware to kind of handle your input and make sure it's legitimate. So otherwise you could just be shoving a bunch of junk into your database.
then we could add the path step. Or wait, no, recipe name page. So in this, I guess, if recipe name is false, it's not going to do it. But so it's just gonna. Ooh. Okay. Anyways, that's for another day. Hopefully that makes sense for this demo. We should be good to handle it, end it here if there's not any other questions. That looks ugly. I'll actually talk a little bit about node versus nodemon. So I'll delete this example for the time being. And so why we installed that nodemon server is so we can refresh our page to rerun our code. So I'll go back just to this route for the example. I stopped my server, but if we ran that with node without nodemon and we run it, it'll be started and we can refresh it and we can say it's like, hello, my name is Cole. But if we made a change here, just a hello world, we save it and then we refresh, nothing's gonna happen. And that's why we use nodemon. It just makes your life easier. If you don't use it, you'll probably like, why is this my code not changing or doing anything? And it might take you some time to figure that out. We should be good to move back to the slides though. And we're just gonna be wrapping up now. It's past 7. But one thing is there's that milestone 2 feedback.
Okay, so we got a lot of good responses for milestone 2. Kind of looking good for learning JavaScript stuff. A lot of people are on the right page. We've got a few just kind of general things that we probably didn't go over super well, but just kind of want to bring it to everyone's attention. So we saw some people using the let declaration for variables instead of var. So we just want to remember let's just a little bit outdated. It's not going to break your code or anything, but it's just not really the standard format we want to use. So go ahead and just use var if you're
Other way
declaring.
around.
No,
Other way around.
use let.
Oh
not
yeah.
var.
Sorry.
Yeah,
Thank you.
var is outdated.
Yeah, var is outdated, so that one you don't want to be using. It's not going to throw any errors or anything, so it's a mistake that people probably weren't seeing, but we want to use the more updated let just for those mutable variables. A little bit of style tips. If you use cursor pointer class styling in CSS, you can do some kind of cool styling with buttons. So I'll give a quick example of that. Yeah, is that your escape?
Just gonna go to the, oh god.
Yeah, so
Oh,
just
shoot.
just an easy example. You can see this kind of on any like Google application, but if we hover over a button here, it's going to change your cursor from the arrow to the pointer. Just kind of a thing that we'll probably be using on our project websites. And kind of a good thing to know. Hide those. And then kind of our main thing, we never talked about this, but adding comments to your code is going to be super helpful, both for you all and for us when we're kind of reviewing your code base, especially because everyone has a little bit different formatting. You know, we're seeing your code for the first time sometimes. So it'll help us out, but it's also really good practice for when you're working on those project teams. You're going to be working on people's code files that you've never seen. People are going to be modifying your code that they've never seen. So just, I'm sure all your professors say this, but this is where it's practically useful, is to actually comment your code. Just put a line saying what your function does. Anything that's more complicated, maybe explain it. That'll just help us and help you all when you go back to fix stuff. Okay, and then we'll talk a little bit about milestone 3. So we'll give a quick demo of it. So if we go around the site here, we can see that it looks pretty much the exact same. On the surface, it's not going to look super different from what everyone's websites are doing so far, but our main difference here is we're using React to build this entire website. So we have components for everything that you see here. So our nav bar on top, the blue bar, that's going to be its own component. We've got our recipe pages and individual recipe slots there as individual components. That way, again, we can just take out that repetition from your code. And this milestone is just going to be converting everything you've been doing on separate HTML files over into React components that you can reuse and kind of work with easier. So it's not going to look super different from what you did before, but it's going to be a lot cleaner and hopefully organize your code a little bit better. Okay. And then we have the Notion page there with a lot of resources. Cole put a lot of good walkthroughs on how to convert your page to React. So that's a good thing to kind of walk through and look at if you have any questions. We've got office hours Sunday and Thursday again, and then right after today if you need any help. And then I think next we have. Oh, okay, yeah. So we do have the feedback form. We talked a little bit about it last week, but we're just going to throw up the QR code right now. If everyone wants to at least scan it and just have it kind of up on your phone to either do now or you can take a couple minutes to do it here. It's just a few quick questions so that we can see how you all feel about Bootcamp. Feel free to roast us if you're not liking the Bootcamp so far, but if you do like it, we do appreciate just any suggestions or comments you may have about it.
And one thing is that React milestone is not going to be due this Friday. It might take a lot longer if you are unfamiliar with React and haven't used it before. So it's actually going to be due the following Friday after this one, so November 12th. Hopefully that'll like give you guys some breathing room at like a pretty good point in Bootcamp. But that doesn't mean start on it late. That means
this is
start on it now, as it can be the most complicated if you've never seen React before or used it before. No, I don't think so. Just remind about the German. Yeah. Oh, hey. Oh, yeah. I think we were pretty good at like ending at the same time. Then still filling it out. Let's wrap it up. It's completely anonymous too, so don't feel bad about roasting, especially Ben. Yeah. Is this like default or like URL keyword code?
Yeah, anytime you just make it on Google Chrome, that's just how it's
Google
going.
Chrome.
Yeah, you can just do it. You literally always use like a right click anything. I guess that's not an actual page.
I've never. That's
so cool. That's cool. That's not like an extension. That's just it's actually sounding.
all right, sweet. So just make sure you get that Bootcamp feedback form filled out. And we just have a few more reminders. We're going to be having a general meeting this Thursday. So it's going to be room 14249. It's going to be at the same time. Make sure you're there like pretty promptly around 6:10 if you can, because I believe we're going to be meeting the nonprofits and they're going to be there. We're going to be valuing their time. So we want to be there and not like a few minutes late. Again, milestone 3 is going to be due November 12th. That's 2 weeks from now, but get started on it earlier, the better. And then thanks for coming. And then as always, us 3 will be sticking around for a little bit to help if you have any questions with your project so far. But sweet, you guys are all free to go. That's it for today. Hopefully you learned some new stuff. That was like hopefully you learned some new stuff. Like,